So for a couple of these, I hope that this one right here really jumped out at you and you're seeing it like, oh, that's got to be a right skewed histogram, and this is perfect one to fit the bill. So that, I hope that was one that everyone was 100% confident about. Okay, so this one right here is got some kind of a left skew, but it's a little bit weird. And so you might not have done this one second, but I think the one that fits this one best is right here. It does have definitely a little bit of a left skew. It's bimodal. It's just a weird distribution, but you know, even if you didn't get that one next, you would have eventually deduced that that one had to be right. So it's these three right here. So 1, 2, 3, where they're unimodal, or well, they're not unimodal, sorry, but they're symmetric, and the center is going to be right in the middle. So I know that it's going to be these 3 histograms. So now the question is, okay, so how big should the IQR be for each of these? Now, if you have almost all of your data, or sorry, not almost all, but a vast majority of your data gathered right in the middle, this is going to have a small IQR. So that's why these two actually match up perfectly. All right, your IQR, you're going to look for where does 50% of the data live? Well, we can already see for number 1 up here, 50% of the data is actually way on the outside. So 50% lives to the left of that line or to the right of the other line. So you're going to have this really wide IQR with 50% in the middle. So that is why these two match up. And then this one right here, because these are quartiles that we're showing in a box plot, 25% of the data should fall in each one of these quartiles. And the way that you make that happen is if it's a uniform distribution. There's no clustering of the data in the middle, which would give you a smaller IQR. It's not spread out to the edges, it's just uniformly distributed. So if those caused a little bit of confusion, hopefully that helps to clear it up just a bit. All right. We are going to be doing some just multiple choice. Now there's not going to be a review day before every single test, but I will tell you generally your test questions come from AP sources or they're modeled based on AP types of questions. So you're going to get your best practice by practicing with AP style multiple choice questions. And we're going to see some of those in class today, but I'm also going to show you where you can get some more practice with that online. And we're going to start that way. We're also going to look at a couple of FRQs. We've kind of talked about FRQs. I want to first of all say that I'm not going to grade you overly harshly at the beginning. I'm looking for you to have the basic right answer. And if you're missing some really important stuff, I'm going to count you off. But if you have like basically right, but it wouldn't be, you know, a perfect answer on the actual AP test, that's not a big deal for right now. We'll kind of develop that more. So there's a few things here, these random notes, and you might want to go ahead and copy this code down real quick because I'm going to show you what this is used for. So if you just want to have scratch paper and just copy that somewhere. And I will put it in the chat just in case someone else needs to reference it later. All right, so it's in the chat now. So let me show you just a few things to get you prepared for the test tomorrow. All right, where does it do this? Okay. So the first thing, I'm going to take you over to the AP classroom. Okay, this is what I'm looking for. All right, but I want to go to just the main modules. And up at the top, okay, well, I should maybe put this in student view so it looks more familiar. And I also want to apologize if my internet's a little slow and a little choppy. In my other classes today, it hasn't been a problem. People have still been able to understand, but if it does get to be a problem, please just let me know. Okay, sorry about that delay. So one thing you might have already been referencing, maybe you haven't ever looked at it yet, there are these Unit 1 reference posters. And I'll just pull them up real quick. These are things that when you're taking your test, you're taking it at home, have these things available. There's no problem with you looking at these things, looking at all your homeworks, looking at your book. You can have all the resources available when you do your test. But this just has some really quick reference to stuff that's covered. And you can see I did not make these, but it's a really great resource I found. So if you kind of want to look through it just for a quick reference on things, that's a good idea. So anyways, don't know. I'm not going to, there you go. There's most of the files. Okay, there's also the AP Classroom, and that's also going to be able to be found here, AP Classroom code. So one thing I'm going to do, and I didn't start off last semester using this, so this is the same thing I posted online. So if you need to come back to this for some reason it's not working right now, you can sign up later. This is what you will use, and you'll go to myap.collegeboard.org. I'm assuming a lot of you have already done an AP class and maybe have already signed up for AP Classroom, so you'll just need to sign into that again. But the AP Classroom, I know it looks different on my end than it does for you, but I'm just going to take you there real quick. And I have to do, for some reason, it makes me do 2 logins when I go, but hopefully it doesn't give you too much grief. Okay, so let me sign in real quick. Sorry about this delay. Okay, so I'm going to go to the progress checks. Now, again, yours does not look the same. If you've already done AP Classroom for another class, you might have already been assigned progress checks for other classes. So this will be somewhat familiar. So when you do the AP progress checks here, I give these to you before your tests. And they are required, though they just need to be done eventually. And they're due by the end of this quarter. Okay, so I do not recommend this, but if you get them done at the last minute, that's fine. But the purpose of me assigning them earlier is because now you have something you can look at, and you can see the styles of questions, all the different types of questions that could be related to this unit. And it's really, really helpful. So I'm not going to run through these problems specifically, but I really encourage you to go through. I mean, I could take this problem right here, change it a little bit, put it on the test, theoretically. So make sure you go through this and you feel comfortable with it. And I encourage you guys to get signed up for the AP Classroom today. And when you sign in, you will automatically have these assigned to you, so you can get started on those tonight. Just as a review thing, I do not grade these for correctness. So if you get every one of them wrong, that's fine. And it will show you the answers when well, actually, will it show you the answers? Maybe not. But you can come back, and what I encourage you to do is, as you're going through, let's say this problem is giving you grief. Then on your paper, you can maybe take a picture of it with a screenshot. And then you could say number 6 on progress check 1A. I didn't understand it. Then you can come to me tomorrow. We can look through it. We can talk about what the answer is. Okay, if you have more questions about AP Classroom and how that's going to be used, please let me know. But I will assign you these progress checks at the beginning of every new unit. And you can kind of keep up with it that way. All right, and the question just came up in chat. Do we need to create a College Board account? You will need to create an account, and you will, once you have the account, then you'll plug in the code. You'll be given the option. If you already have an account, you can just add this to your other classes. Okay, if there are more questions on this, please stick around and we will go over that in more detail. But sign up for that today and look over the AP progress checks. There are 2 of them. There's Unit 1 Progress Check A and Unit 1 Progress Check B. And combined, it's about 30 questions. Okay, so for the rest of today, I already picked out some problems, and I'm just going to run through them. And I think it's fastest and probably I know it's not the most interactive, But if I run through the questions and how to solve them pretty quickly, then we don't spend an hour and a half here and we can get out a little faster. You probably appreciate that, I imagine. So let's go ahead and get started. All right, so these are not the same questions on your progress check, but they are other AP style questions. So in a certain school district, students range from grades 6 through 12 can participate in school-sponsored community service activity. The following bar chart shows the relative frequency of students from each grade who participated in the community service activity. So keep in mind, this is relative frequency. So the question is, of these statements, which one is supported? So the greatest number of participating students was in grade 9. We don't know anything about the numbers here. There could be 150 sixth graders, but only 100 ninth graders. And there could be all kinds of different numbers for every grade level. We don't have that information, so we can't say anything related to the numbers of people involved. We can just talk about the frequency. So not that one. The number of participating students in 6 was greater than. Again, we don't know the numbers, but C, the relative frequency of all participating students in 6-7 combined was 60%. Well, this I'm going to come back to. Grade 12 had the least relative frequency of participating students. That one looks very promising. So I'm going to put a star by that one. Grade 11 had the greatest relative frequency of participating students. Almost, but not quite. 9 seems to have slightly higher. So this is our answer. And I want to go to C and say, show why that's not the case. So 30% of 6th graders participated, 30% of 7th graders participated, and you might already intuitively know what the combined relative frequency is. But if you don't, let's just imagine what this is. Let's say there were 100 6th graders, and I'm going to go with simple numbers. There were 200 7th graders. 30% there is going to be 30 out of 100. 30% for the 7th graders would be 60 out of 200. So if I had the total amount combined, I'm going to combine these two together, and I get 300 total participating. Combine the top, I've got 90 total, 300 total students, 90 total participating. Now, if I get that, that is still 0.3. All right, so the combined relative frequencies are going to stay at 0.3. Okay, so if you need numbers to make that intuitive for you, there you go, just to make that make sense. Okay, the following table summarizes number of pies sold at a booth one day at a local farmer's market. Which of the following is supported by the table? Well, one thing that might help is to have a total number of pies that were sold. And we'll see if that matters for the problem. But I can just combine 18 to 12, 18 to 12, that's 60 plus another 30. It looks like 90 pies were sold. You guys can double check my count. I think that's right. So more cherry pies were sold than any other type of pie. No, that one's very easy to dismiss. Twice as many apple pies as key lime. No, that's another. Some of these are like really kind of, hopefully some of these are really like junior high or even elementary school type answers that you could quickly eliminate. More than half the pies sold were apple. Well, 18, and this is where it helps to have the total. Not that you'd necessarily need it, but yeah, we can see that's not true. Fewer than 50 pies were sold at the booth that day. Now it's good that we have the total. That's not true either. It better be E. The combined percentage of key lime pies sold and pumpkin pies sold was less than 50%. Key lime and pumpkin, that's 30 pies total. So 30 out of 90, that's 1/3, so 0.33. So that's less than 50%. There we go. I always get kind of nervous when I get down to E and nothing's correct. I'm like, oh, either it has to be E or I did something wrong. But looks like it worked out. Okay, question 3. Number of video games sold at a store each day for 1 week. The best classification. Oh, this is something I totally forgot to cover. I'm glad we're doing this today. Okay. This is, now you can quickly determine if this is categorical or quantitative. So hopefully you're immediately thinking it's quantitative. So that gives us, we can cross this one out, this one out. We know it's going to be quantitative, so I'm stuck with one of these two answers. Now, the thing that I forgot to talk about, luckily it's not a very complex idea, is are we talking about continuous or discrete data? And with continuous, you learned about continuous functions in previous years, and I'm not sure if discrete ever came up, but continuous means that, well, let's start with discrete actually. If you were selling video games, you can sell one video game, you can sell 10, you can sell 11, 12, but you can't sell, I sold 12 and a half video games this week. You either sold 12 or you sold 13. You can't sell in between. So those are discrete values. And if you created a histogram of this, your values would all, like if you created a dot plot rather, they would all fall, on these discrete values, 11, 12, something like that. But you can't have anything in between. Now, you can still have decimals. Let's say you're talking about shoe size. Well, 11.5 is a shoe size. So maybe we're talking about shoe size now, and you have some people there. But you can't have an 11.75 shoe size. So the point with discrete is that you have specific values that your variable can take. And continuous means any value is possible. So if you're measuring your weight, you could be 121 pounds, you could be 122 pounds, you could be 121.532 pounds. Any value is possible. So anyways, continuous versus discrete, all values are possible for continuous, only certain values are possible for discrete. So in this case, we would call this quantitative and discrete. All right, are there questions on this? Since that's a new thing I threw out there. Okay. Again, not the most complex idea, but it is just some more vocabulary you need to remember. Okay, veterinarian collected data on the weights of 1,000 cats and dogs treated at a veterinary clinic. The weight of each animal was classified as either healthy, underweight, or overweight. So we got a two-way table, a contingency table, lots of different names for this. Which is the most appropriate type of graph to visually show whether a relationship exists between the type of animal and the weight classification? All right, now some of these we didn't directly talk about. We did talk about side-by-side box plots and things like that, but keep in mind a box plot, this is for quantitative data. So I'm not going to use it. This is categorical data. All right, because we have categories. All right, a dot plot, that's for quantitative data as well. So I want to ignore that. Stem plots, back-to-back stem plots, I did not really talk about that, but if you have your stem, you probably learned about it in the chapter. But if I've got my stems going up, and I'll just say I've got some leaves coming over this on this side, I could compare two different distributions by, having stems going, leaves going off on either side. So this maybe would be male and female, or Republicans and Democrats, any two categories you wanted to split it between. All right, it's not going to be back-to-back stem plots because that's still for quantitative data. A scatter plot we haven't really even looked at yet, but that's quantitative as well. That's when we have two quantitative variables, and that will be unit 3. So the only option here is a segmented bar chart because this is for categorical data. And of course, you know what those look like. You'd have dogs and cats and some kind of splitting up therein. Okay, I know I'm going through this stuff a little bit quickly, but remember, put a star next to any of these problems if they're like, I want to go back and investigate that one a little more in depth. So here we can see some segmented bar charts, relative frequency bar charts, that is. Okay, so we've got community service program and participation in different activities. What must be true? of all the students who chose activity B, the greatest number were in grade 6. Because this is relative frequency, we don't know anything about numbers. So we're going to cross that one out. Grade 7 and 8 had the same number of students who did not choose activity A. I don't know. We don't know. The grade with the greatest percentage of students who chose C was grade 8. So there we go. Now we're talking about the percentage of students who chose activity C. So it looks like the greatest percent who chose C was grade 7. So that's not correct, but we're on to something with that. For students in grade 7, the number who chose activity C was greater than the number who chose activity B. I still don't know any. Let's see. Here's where actually the numbers we can work with, because we're not talking about comparing between two different segmented bar graphs. We're talking about within one. The number who chose activity C was greater than the number who chose B for grade 7. So C looks to be about 40%, and B looks to be about 35-ish%. So within grade 7, more people did choose activity C. I don't know the numbers, but I can definitively say that the number is higher than the number of 7th graders who chose B. So that one looks good. Now for students in grade 8, A was greater than B. Here's activity A. There's activity B. That one's definitively not true. So there we are. Okay, assuming no questions, I'll move forward. Some of these are going to go a little faster. At a local ice cream store, 210 people were surveyed on whether they preferred eating ice cream from a cone or a cup. Of the 210 people surveyed, 70 were adults, 140 were children. Okay, of the responses, 150 indicated the cone as a preferred method of eating ice cream. For those surveyed, there was no association between age and preferred method of eating ice cream. Which of the following tables shows the distribution of responses? So first of all, our age distribution, our marginal distribution on age was going to be 70 adults, 140 children, and that's found right here. All of these are the same, so that doesn't rule anything out. 150 indicated cone, which means 60 would have chosen cup. And again, that appears to be the same marginal distribution for all of them. So we're good on this so far. So now we need to think, what is it that makes this independent? All right. Well, we want to have it so that the idea that if I told you that an adult, what happened here? That an adult was selected randomly, that wouldn't give you any indication. All right, so let's kind of think about it this way. If 150 out of 210 prefer the cone, I'm going to figure out what that's the overall, what's the word I'm looking for? That's the overall preference. All right, so 150, if I divide that up, that's going to be 5/7. All right, so 5/7. Now, if I just look at adults, there's 70 adults. And 5/7 of the adults, because the overall population prefers cones at a 5/7% probability, then adults should prefer this 5/7 of the time. So I can just do 5/7 times 70. And when I do that, that's going to give me 50. So for adults, I want to find where 50 prefer the cones. And it looks like right here, that's what I've got. So if you follow that logic, then it looks like C is our answer. Okay. All right. Now in this one, we are basically just talking about what statement is correct. Or let me see, what statement about delivery method and rate of survey return is supported by the graph? So we have different forms of giving a survey and the rate that they returned it. And you can see the graph shown there. So there is a positive association between delivery method and rate of return. There's a negative association. These we need to rule out. All right, this is just categorical data. I could have flipped the order of this. I could have put in class second and psychology first, but we just happened to put it in an order, and there's no association between this as far as positive and negative associations go. So I want to rule both of those options out. All right, the number of surveys given using the dining hall delivery method was less than the number given. Well, let's read a little more. Does it appear that that's the case? So they said they prepared 3 sets of identical surveys and used 3 methods for delivering them. I don't see anything about them delivering different amounts to each person. And we certainly don't have any information of each type. So we don't have any information on that. So I'm just going to put, a little note on that one. Probably not true. The psychology delivery method displays the most symmetric results. The other delivery methods display skewed results. We only have skewed distributions whenever we have quantitative data. This is categorical. So that's not true. The in-class delivery method had the greatest rate of return, and the dining hall delivery method had the least. That's very clearly shown. All right, so there we are. Is this fun? Are you guys having fun?
I'm having the greatest time of my life.
Good, I'm glad to hear that. I sure do love hearing my own voice. If only I could also be on the Zoom call hearing me at the same time. Okay. The prices in thousands of dollars for 304 homes recently sold in a city are summarized in the histogram below. Based on the histogram, which of the following statements must be true? The minimum price is $250,000. Remember, we talked about this. This is a bin. That doesn't have to be true. Maybe it's at $250,000, but it could very well be at like $200,000 or $300,000 is the minimum, because these are pretty big bins. So no, that doesn't have to be true. And it says must be true. The maximum price is $2.5 million. Again, that's not true. The median price is not greater than $750,000. The median is not greater. Let's come back to that one. The mean price is between $500,000 and $750,000. I think it's fair to say, without doing math, I don't want to do any math on this, if I can help it, the mean is going to be pulled toward the tail. So I would guess the mean is going to live somewhere in this range. I don't know where, but I think it's going to be greater than 750,000. So I'm going to go ahead and rule that one out. The upper quartile of the prices is greater than 1.5 million. So now let's kind of think about this. We have a couple things related to quartiles. 304 homes, the median is going to be between 152 and 153 when I put these in order, right? So I've got 1, 2, ... 152, 153, ... 304. So my median lives right here. So if I can figure out where 152 and 153 are, well, I know that my cumulative total, I've got 38 after I look at the first bin, and I've got 158 when I look at the second bin, when I combine those two together. So the median is going to be in this bin right here. Doesn't matter the value. So what must be true? The median price is not greater than 750,000. Yeah, it's not greater than 750,000. That's true. That must be true. And we could do the same kind of logic to figure out why E is not true. If we divide this by 4, let's see, that's going to be like 76 is 1/4. So 76 is going to put me, just quick math, is going to be somewhere around here. This is Q3. So the upper quartile is going to be way below 1.5 million. Okay. Question 9. A graph of the selling prices of homes in a certain city for the month of April reveals that the distribution is skewed left. Which of the following statements is the most reasonable conclusion about the selling prices based on the graph? This helps to actually draw a graph. It's skewed left, so I'm just going to draw a very quick distribution. I know that the mode is right here at the hump, so the median is going to be close by. I know that the mean is pulled in the direction of the tail. So now the mean is greater than the median. No, the median is the average of the first and third quartile. Well, that's interesting. Let's come back to that one. Well, let's just do that one. So the median being the average of the first and third quartile, keep in mind, you can have box plots where the median is right in between these two, and that distance and this distance are equal. But you have box plots also that look like this. And this distance right here is way less than this distance right here. So it's not the average of your two quartiles. So I think in this case, we're going to end up with a skewed distribution that looks something like this. All right, I'm making this up slightly, but I'm making everything up. So it's not going to be the average of those two because it is skewed. If it was symmetric, that might be more believable, but it's skewed. There are fewer selling prices between the first quartile and the median than there are between the median and the third quartile. There's always the same number in every quartile. So that's not true. Every quartile contains 25% of the data. There are more selling prices that are less than the mean than selling prices that are greater than the mean. Let's look at E real quick. The value of maximum minus third quartile is less than the value of first quartile minus minimum. Okay, so these get kind of complex and we have to think through. So let's see this. There are more selling prices that are less than the mean than selling prices that are greater than the mean. Well, since my mean was pulled below the median, I'm just going to draw a dashed line right here and just pretend that this represents the mean. So I know that less than 50% are going to be below the mean, and more than 50% are going to be above that because the mean was pulled to the left. So therefore, there are more selling prices less than the mean. No, it should be the other way around. So this one's not true. If by deduction you come up with E, then you're good, but we can make sense of this one as well. The value of the maximum minus the third quartile, here's my max, and third quartile. This is skewed left, so this should be a pretty small gap. That distance is less than the value of the first minus the minimum. Here's Q1, and here's the min. So this distance is going to be bigger than max minus Q3. So it takes quite a bit of wrapping your head around it, diving deep into the concept for this problem, but it does turn out that this is true. And just to repeat myself some more, if that doesn't make sense, if you have questions, put a star by that one. We can come back to it and look at it again. And if any of the progress check problems give you some grief and you don't know how to solve for it, bring it to class tomorrow and we'll go over that. I already said that earlier in class, but you'll find I repeat myself a lot. A group of students played a game in which they earned points for answering questions correctly. The following dot plot shows the number of points. So basically they just want a quick description of this. So pretty clearly, I think we agree that it's bimodal. I would not call it normal. Normal means unimodal and symmetric, and that's going to be very obvious in the next unit. So it's not normal. Bimodal without a gap, bimodal with a gap, skewed to the right, skewed to the right, blah, blah, blah. So that one shouldn't, I'm not going to talk about that one too much. We should all agree with that. Okay, resting heart rates. We got some people who are 20 to 30, others that are 40 to 50. We've got the 5 number summaries shown. Okay, this kind of question is Very interesting. All right, so we are working with outliers. So the values 60, 62, and 84 were in both age groups. But let's see, for the age 20 to 30, they were outliers. So the question is, using the same method, which is at 1.5 times the IQR above the upper quartile and below the lower quartile, using that method, which of these are outliers for the 40 to 50 age group? So here's what we want to do. We just want to kind of approach for the 40 to 50 data. We want to approach where are the fences going to be set at. So I've got a box plot of some kind. And there are going to be fences that are set. Where are those? So my minimum here is 60, and then 70, 73, 76. You don't have to draw a picture for this. You might find it helpful. All right, so if I'm looking to find out where the fences are set, first of all, I need to know the IQR. The IQR is going to be 76 minus 70. That's Q3 and Q1, the difference between them. So the IQR is just 6. Now 1.5 times that is going to be 9. So what I want to do is I want to figure out where the fences are going to be. So 76 plus 9 puts my fence actually right here at the max. And then 70 minus 9 puts it at 61. So my fence, I'm going to get rid of it over here. And I'm going to draw it right here. 61 is my fence here. 85 is my fence up above. So of the 3 outliers that we had before, the only one that's still an outlier is 60, because 62 and 84 are both within the fences. So now here's my answer. So technically what I would do is I'd put my whisker right here, and this would be a star, but we don't care about the actual graph for this, the actual box plot. Okay, next one. Graduate student conducted a study of field mice in rural Kansas. Don't you want to be a grad student? The student obtained a sample of 100 field mice and recorded the weight in grams of each mouse. After the measurements were taken, it was discovered that the scale was not calibrated correctly. The student adjusted the 100 recorded measurements by subtracting 3 grams from each measurement. Which of the following statistics for the weight in grams of the field mice has the same value before and after the adjustment? All right, so what values have stayed the same? We talked about this a little bit, but now it's worth kind of reinforcing the idea. And I will just create another box plot. All right, so I'm about to write that wrong. So my min, doesn't matter what the numbers are, Q1, median, Q3, and max. These are just data points. These are actual values from the data set, or sometimes they're interpolated from the data set based on like the Q1 and the median. But this comes from the data. So if everything was calculated or was measured incorrectly, and we needed to adjust it by 3 grams, then all these are going to lose 3. All right, so the things that are changing, the median is changing, the first and third quartile are changing, the mean, because every value is now 3 less, the mean is going to lose 3 as well. So the only thing that doesn't change is the interquartile range, because this is straight. This is just a measurement, a distance, if you will. So the distance between these two relative values has shifted a little bit, but not the absolute distance between them. So this, no change in this at all. I don't know if I explained that one clearly enough. So again, any questions, feel free to speak up. You don't have to wait till the end to ask questions. If something doesn't make sense along the way, you can just jump in and ask questions. Okay. Not too much more. Oh, do I even want to talk about this problem? Do I? All right. This is a really good question. I don't want to talk about it now. I might find some time in class to talk about this another time. You're not going to have a question like this on the test, so I'll just tell you that right up. Question 14, we've got a distribution. It is a histogram. What is the closest to the interquartile range in inches of the distribution? So we know that there are 100 adult men. The interquartile range will actually be, well, okay, here's what we need to think about. Where is the first quartile? Let's focus on that. Q1 is going to be somewhere between, if I start listing all the data points in order, so I got 1, 2, ... up to 25 and 26, and then ... It goes from there. So right here is Q1, because this means below that value, 25% of the data is going to live there. So I want to figure out where the 25th and 26th data points are. So here's 1, 2, 3, 4, 5, 6, 9, 13, 18, 24. And then that's going to put the Q1, I'll just put Q1 right here. Q1 is going to live somewhere in this bin. I don't know. Well, it's going to be 66 inches, right? So Q1 is going to be 66 inches. So what I also want to think about is that Q3 is going to be where, I'll just start at 60, so ... here's 60, 61, ... we go up to 75, no, actually 74, and 75, ... up to 100. All right, so all these are just data points in order. So my Q3 is going to live right here between 74 and 75, because that means anything to the right of that is going to be 25% of the data. So now I want to count backwards from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 14, 20. Okay, here's Q3. It's going to be in this bin right here, which is 71 inches. So what's the closest to the IQR? 5. 71 minus 66 is 5. All right. So you can tell that I don't have time in class to go over every type of question. This is what these days are set aside for, like, hey, here's a bunch of things you could be asked. And, it's good to kind of see all the different nuances. So a random sample of 1,092 people were asked whether color was a consideration in buying a new car. Okay, let's see. Those are some responses. We know this might be important to know, so I'll keep that out. Oh, it's already right here. Okay, which of the following is closest to the proportion of people who responded no to color consideration and who identified safety as an additional feature that was important? So this is where we're getting into kind of conditional distributions and things like that. But this one's, you're not going to be asked a question exactly like this, I don't think. Maybe you are, so we can talk about it right now. So which of the following is closest to the proportion of people who responded no to color consideration? So they're in this column right here, and who identified safety as the additional feature that was important. So they're in this row right here. So 192 people fit both of those criteria. What's the probability? Well, I say probability, that's going to be the idea later. What's the proportion of people? It's going to be 192 out of 1,092. So if I do that real quick, that gives me about 0.176, and that rounds up to 0.18. So we have to be careful, and you had some homework like this where you have to identify, are we talking about just a proportion of the total, or is it a conditional probability? And this is, I will tell you, where the most misses were made. So as you're going through and you have questions like this with two-way tables, be very, very careful about how you're reading it and determining, is it a conditional probability? Are they saying what proportion of people out of those who said no to color consideration chose safety? That would be conditional. This is not conditional because it's saying which out of the total had both of these characteristics. It's a little distinction made there, and hopefully you heard what it was. But if that's still confusing to you, you can practice with the progress checks and you can come back tomorrow. We can look through anything. Okay, the very last, well, actually there's one more. So this is one, it's all about standard deviation. This is not a major thing for this chapter. I'm gonna go ahead and tell you that we can rule these out because I wanted to get to the heart of this question. We have two symmetric distributions. They both have the same mean. They both have the same median. They, so they're all, the range is the same, most likely. Okay. So, no, when I say they have the same, they have approximately the same. So there's only one thing that must be true here. And when you have a lot of your data in the middle, you end up with your model that looks like this. This is going to be, bimodal. So what happens to this is your standard deviation, if here's your mean for both, your standard deviation is going to be far wider for this one than it is for this one, which is going to be about right here. So your standard deviation gets wider. This is really a unit 2 question, so there's not anything like this on the test. We didn't talk a lot about standard deviation, but remember we did say that your standard deviation is the average distance any point is away from the mean. And your average point is further away from the mean on this than it is for that distribution. So the standard deviation of A is going to be greater than the standard deviation of B. Okay. All right, we're comparing some box plots. All right. Oh, yeah. Approximately half the trees were fertilized yearly. The remaining were never fertilized. Which of the following statements about the median and interquartile range is true? So unfertilized median is lower. So let's just focus on that. We can see the median for unfertilized is lower than the fertilized. So I can, right here saying the medians are the same, that's not true. Medians for unfertilized is greater, that's not true. Same. So the median is less, so we're good. The IQR, which one's greater? It looks like the IQR here, that is going to be greater than this. So unfertilized also has a greater IQR. IQR is greater for the unfertilized trees. All right. Again, this is pretty fast going through all these problems. So there you go. Here's what an FRQ will look like. And you can see right here, compare the distribution of percents of seniors who took the college entrance exam for the two regions. These are two different regions of the country, region 1 and region 2. And they recorded the percent of seniors who took the exam. So there we go. You can see there's an obvious difference between those two. What we want to do is we want to compare. We want to use also comparison words like greater than, less than. So if we're talking about the distribution here, we can't necessarily say it's unimodal or anything like that, but we can say that the region 2 looks to be approximately symmetric distribution. Based on that box plot, it looks symmetric with an outlier. The region 1 distribution looks to be potentially skewed, maybe a bit to the, it's hard to say. if you want to say that's skewed to the right or to the left, because you have a long tail on the left, but you have a longer third quartile right here, that distance rather, between your median and third quartile. So you can just describe that distribution in some way. You could say it's not symmetric, but see, lots of different ways you could describe that, I guess. So I might say it's slightly skewed to the left. That's probably what I'd end up saying. Now we want to use comparison. So when we're talking about the spread, we want to say that the range of region 2 is, well, we'll need to do some math to figure it out, but the range here goes from, looks like about 4 to 28. And the range here goes from about 62-ish to 84-ish. And I'm making up some numbers based on my best guess. So my range for this one is about 22. Now I'm kind of contradicting myself because I said if you have IQR, use that. So let's focus on the IQR. Anyways, we can figure out the IQR. We could say that the IQR is bigger for region 1 than it is for region 2. We can put the exact numbers on that. We can talk about the center. The median is greater for region 1 than it is for region 2, and we can put the specific numbers. So if that's a median of 73, and this is a median of 8, we can show that. And of course, the unit is percent. Okay, so that's just the comparison. And is there anything else? I think you could maybe work with that. If you combine these two, what would it look like? Well, the combined histogram would probably be bimodal. So there we go. That's part B. So my point with this is not that I want you to focus on this specific problem, but answer it in complete sentences. And I'm being lazy right now and I didn't do it, but I would write out my disco description and I would use comparison words like greater than and so on like that. For the next one, I would describe this. I would say bimodal with a median approximately, well, I would just guess that we're going to have the same number in each. So the median might be approximately 40 to 45. So I would write out full sentences with all that information. And now we're getting to the limit of how long you can listen to one person talk. We're almost done. We've already reached that limit, but we're almost done. So here you can see they give us a key to a stem and leaf plot. So we're good with that. This is how much college students spent on textbooks. And the key is in hundreds. So I don't know where they went to college, but $310 for textbooks is cheap. You guys probably know that. So there we go. Describe a procedure for identifying the potential outliers. So what they want us to do is actually write out the IQR method. We could say I could identify the first quartile point and the third quartile point, find the IQR, multiply that times 1.5 and add it to Q3, subtract it from Q1. So you need to actually write out what that process is. All right, based on the stem plot, write a few sentences describing the distribution of money. So here's where we could describe this. Because this is almost a histogram turned on its side, I could do something like this, and then of course we have a little outlier up there. But we could almost turn this into a histogram like that, and I could describe it. You don't have to draw it, but it's always helpful to show it. Now you could say this is unimodal, skewed right, with an outlier at 81, or 810 rather, and go through the full disco description of this. All right. Hopefully this has been helpful. I don't pretend that this is answering everyone's questions and clarifying everything from this unit, but
Hey,
we,
quick question, real quick, Mr. Davis.
yeah,
So when you're looking at one of those, and for the 7 section, there was no numbers, would that just be 700, or is there nothing there for 7?
good question. That means there's no data point for that. So if you listed all these out, you'd go from $620 spent to 810.
Okay. If there was something, would there be a 0 there?
Yeah,
Okay.
or yeah, whatever the tens place was would show up. So that would be a
Right.
data point. Good question.
Thank you.
Mhm. All right, I do have, and I hope they're already posted. I will go and make sure they are right now. If they're not, I do have a couple of FRQs, and I encourage you to do those for homework tonight. Remember, you don't have to turn them in, but one of the FRQs, if you go through it tonight, will appear on your test. So that is a good thing to know. All right, I need to stop talking. Have a wonderful day, but stick around if you have any questions.